Up until this point, the demonstrations have shown a lot of the offline capabilities of the RCAD software. Time has come now to demonstrate the online capabilities that RCAD 4 can benefit users with. Before you can start using RCAD 4 online with an Infi90 system, there are a few things that have to be set up. To begin with, activate the RCAD 4.0 server program by double-clicking on the icon on your desktop. I've already started it here and the server is now displayed. To begin with, users have to configure the COM port of the computer on which the server is executed. To do that, click on the File menu and set up COM port. Here you can set the COM port, the baud rate, parity, data bits, and the stop bits. When you're satisfied that you have the values correct, click OK. The COM port is now set up, ready to communicate with an Infi90 system. Set your CIU type, whether or not you're communicating through a CIU 01 through to an 04, CIC 01, CPM 01 through 03, or the ICI 01 or ICI 03, or whatever type of CIU you are talking with. Now, the communications between the client and the server in the RCAD 4 system architecture uses TCP/IP to communicate. TCP/IP gives us the ability of sharing one single CIU connection through a serial port through multiple clients that attach to the server via TCP/IP. This way, users can be monitoring CAD drawings and uploading and downloading configuration files all simultaneously. There are a few options that should be set as well too before we actually execute and start the server. The first option is the monitor cache. The monitor cache, when checked, permits monitored data values to be automatically updated and refreshed inside an internal memory buffer set up by the RCAD software. The server, when it is not busy communicating with a client that is attached to it, will run out over the serial port and update the values that are currently located inside the monitor cache. This value should normally be checked. There's a TCP/IP test mode as well too. This can be used to test communications between a client and the RCAD 4 server. Checking this and clicking the Start Server button shows that the server has actually started. There are no connections coming in from a client. So to simulate and test the TCP/IP mode, we can configure the RCAD 4 client to talk with this particular server. If you'll notice up at the top here, we've got an IP address that belongs to this computer. This is the IP address that this RCAD 4 server is listening on. So to get our client to actually initiate a conversation with the server, we have to configure the client to do so. To do that, click on the Setup menu and configure RCAD from the RCAD 4 client software. Uncheck the offline mode. This now turns on the online capabilities of the RCAD 4 client. Type in the IP address and the port address. You may also want to type a description in there and add it to your queue of available servers. Once this is configured, click the OK button, load up a project, double-click a CAD drawing, and in the client, you'll see at the bottom here that it is actually connected now to the server. To verify this, open up the server and note that the number of connections has now increased from 0 to 1. If I terminate the client, the CAD editor in this case, you'll notice that the number of connections now drops down to 0. We have successfully tested that we are communicating via TCP/IP from the client to the server. The beauty of having TCP/IP as the means of talking between client and server means that users can put a server on another computer, turn it on, and make it execute, and talk with the Infinity system, and clients can come in from other computers as long as they're attached to the same network. Two other options are available here in the RCAD 4 server. Run as an NT service. If this is checked, whenever the computer boots up, the RCAD 4 server will automatically start and run. The permit serial port flush is used for desktop type computers that use true serial ports. If a user is using a USB to serial port connector, uncheck this item, as USB items will automatically issue a flush command whenever a protocol is sent across the serial port line. Now I have another server attached to another computer, so for the rest of this demonstration I'm going to terminate this server and we'll actually reconfigure to talk with that other server. By doing this, all you have to do is go back to your setup menu in the RCAD 4 client, double click on the new address. The new IP address and port numbers are set for the new server, and now I can double click on any CAD drawing, and as you can see down here in the bottom, I'm connected to that server. To monitor values in a CAD drawing, click on the monitoring button at the top here. Now it takes between 2 and 3 seconds for the data to come in, but as you can see, RCAD will monitor both the inputs and the outputs of all blocks, as well as cross-reference bubbles, both IREFs and OREFs, and IREF-Os. It should be noted that cross-reference bubbles will only be monitored so long as the cross-reference database has been set up in the client project. There is a 1-second refresh period for monitored values. Another nice little feature of the RCAD client is that if you move the mouse over one of these monitored points, Balloon Help will pop up showing you specific information about the monitored point. This information will last for approximately 15 seconds and then fade away. If you move the mouse over top of a block output, you will see the block number, the frozen value, and whether or not it was in alarm. If you move it over top of an input specification, you will see all the previous information just mentioned plus the source block as to where that signal is coming from. Users can also tune blocks by identifying the block, right-clicking, and selecting item properties. In this example, I'm going to actually tune the block while we're monitoring in the background. As you can see, the values are slowly changing here. To tune a block, identify it, take a look at the item properties, and change any specification value that you wish. In this example, I'm going to change the high alarm to a value of 30 and the low alarm to a value of 10, and then click the Tune block. The CAD editor will walk out, connect through the server, and tune the block automatically inside the module. And now you can see, because I have tuned the high alarm value of this AOL block, the monitored output is now in alarm. The default color for alarm values, whether it be high, low, or deviation type alarms, defaults to a red background on the monitored value. Now when I move the mouse over it, you can see the balloon help indicates that yes, it is in alarm. Even while I'm monitoring, I can move blocks by rubber banding, dragging the block, and the monitored values are moved with it as well too. One of the most powerful features of the monitoring is the ability to trend the specification values coming into PID blocks. To do this, identify a PID block, right-click on it, look at Item Properties, and there'll be a button here if this is a function code 19, 156, or 160 Smith predictor type blocks. Click on the Trend PID button and the dialog box expands to show you a trend. Users can trend the process variable and set point as well as the control output of the block. If there is a station block attached via specification 4 of the PID block, you can have control over the station and set your control output and the station mode, as well as the set point. To begin trending, click the Begin Trending button. With this example, though, there is no station block attached via Spec 4. Therefore, if you wish, you can manually enter in a station block. This kind of situation arises if you're using a cascaded loop. In this case, I'm not going to, and I'll just click No, and I'll just take a look at the PID values itself. I'll turn the grid on by checking this box. And this grid can store up to 24 hours of information. This grid is very useful for people who are performing tuning operations on their PID loops, because users can walk up into the specifications and change the values for their proportional, integral, and derivative constants, and click the Tune button to tune it while you're actually trending the values. This data can also be exported out to a CSV file for importing into Microsoft Excel. Right-click on the grid and click on the Export Data to CSV pop-up. Specify the name of a file and it'll save it. Users can then use Microsoft Excel to import the data for further data analysis. When you're finished trending the values, click the Stop Trending button and then click OK. Turn off monitoring by clicking on the monitoring button, which is basically a toggle switch. Monitoring is now off, but we are still connected to the server. If we wish to remonitor again, click the monitoring button. Users can monitor up to 16 drawings simultaneously at any given time. Now to show how configuration files are loaded and saved from modules. To do this, go back to your RCAD 4 client and click on the Configuration File Utilities tab. Click on the Upload Download CFG button. This activates the configuration loading program. To see what is inside the PCU cabinet of the currently selected module in your client program, click on the Pull PCU button. You will see that we are automatically connected to loop 2 PCU 9. We are connecting through an ICIO 3, and the CIU node address is loop 4 node 33. As well too, our TCP/IP connection status is indicated, showing us the IP address and port number of the server that we are connected to, and the connected indicator here tells us that we are successfully connected to the RCAD 4 server. After clicking the Pull PCU cabinet, the left-hand side of the configuration loading program populates itself with the available modules inside this PCU cabinet. To see what's going on with one of these modules, select it. It'll tell you in the status bar the PCU address and the module address and the module mode. As well too, you have access to that information plus the status bytes of this module. To see an English interpretation of these status bytes, click on the question mark button and a new dialog box pops up showing you the breakdown of what the status bytes mean. To save a module configuration, select the module you wish to save. Click on the Run menu, and some of the items in the Run menu will not be available for execution due to the fact that the module is in the execute mode. When we change this module into configure later on, other items will be available for use. So to save the module quickly, click on the Save CFG File to Disk menu item. This pops up a new dialog box that allows you to save the configuration file. Now the configuration header information is read automatically out of the module header file stored where the CAD drawings are for this module. The module type and the firmware revision are automatically read as well too, and the date is set to the current date. Select a file name to save the configuration file to by clicking the Browse button, and you'll find that you are in the same subdirectory as the module's CAD drawings. Type in the name of a configuration file and press Enter. If you wish to save the basic C or Fortran programs in an NBS file, check this box as well too. When you're ready to save, click the Save button, and the module configuration will be saved to the disk. After it's finished saving, it'll verify it by reading it out of the module again and comparing it to the values stored in the configuration file. When you are finished, it will notify you and click OK. Then click OK to close this off. You can go back into your client, and here's the name of the configuration file that we've just saved. If you wish to view the contents of it, double click on it. This invokes the configuration file editor. Users can double click on any block to see the internal specifications. To change the module mode of any module, select the desired module. In this case, I've decided to select the backup module of a redundant pair of MFP02 modules. Click on the Run menu and click on the Change Module Mode. Right now it indicates that the module is in Execute. To put it into Configure mode, change the module mode to Configure and click the Change Mode button. A prompt comes up, which is a security check, and it asks you, are you sure if you wish to put this module into Configure mode? Click OK if you really wish to. Now, the configuration loading program indicates this module is in Configure mode by highlighting it with a red box. To perform an online configuration change to this redundant pair of modules, click on the Run module and now click on the Enter Online Configuration. A new dialog box appears showing the faceplates of the modules as they exist out in the PCU cabinet. The LEDs on the faceplates flash in real time. Now users can opt to add blocks manually, or they can modify blocks via this dialog box. To add a block, click on the Add Block button underneath the module that is flashing with the green LED. This is the module that is the backup module and is currently in Configure, as you can see by the status up here above that module. Users can now enter in any type of function code they wish, as long as they follow the rules employed by the Infi90 system for doing online configuration changes. So I'm going to add a high-low block, and I'm going to add it in at block address 5000. And I'm going to try to write this block into this backup module by clicking the Write Block to Module button. When I do that, an error box comes up saying that the block number is not the highest in the current segment. Do you wish to write it anyways? What has happened here is the RCAD software has determined by talking with the two modules, the primary and the backup, that the address that we're wanting to add to this block does not follow the rules of online configuration changes. This is a nice little feature built into the RCAD configuration loading program to make sure that people follow the rules as to how to perform an online configuration correctly. In this case, I'm going to say no, it's not going to write the block, and it informs me that the block write has been canceled. So let's set the block address up correctly. I'm going to specify block 9750 now and write the block in. Now that's given me an invalid block number. Let's try a little bit higher. It still not follows the rules, so I have to determine exactly what is the highest block. Let's go back to the configuration file that we just saved, and there it is there, 9810. So if I put a block in at 9811, it should follow the rules correctly. Let's try 9812. Block successfully added. Okay. Now our block is in there. And you'll notice that the LED at position 7 in this module is now flashing. This indicates that the backup configuration is different than the primary. So how do we get the backup configuration to switch over into the primary module? Well, to do that, we click on the Execute button. And we wait until the LED drops from position 7 to position 8 in the backup module. Now this has happened rather quickly because we're communicating with a simulator here. In the real world, this can take up to 30 seconds to execute. When it has dropped down to position 8, click the reset button underneath the module that has only one LED, and it's so long as it's in position number 8. A message box comes up and says, "Are you sure you wish to reset this module?" You click yes. Now the two modules will switch position. And you wait until the backup now on the left-hand side, LED 7 drops down to position LED 8. When it has happened, you click the reset button underneath the new backup, and then we're finished. The online configuration change has been performed. To verify this, let's go into the primary module, and let's do a save of it. And then we'll examine the contents of the last block in the primary module. Now the configuration file is saved. I'll go back out to the RCAD client, and here's the new configuration file. And here's our new our new high-low block that we've just put in. And to demonstrate the ability of the RCAD server to simultaneously accept multiple clients coming in the CAD editor here, which is one client program, I'm going to turn monitoring on. And in the configuration loading program, I'm going to actually save the configuration once more. I'll overwrite the configuration file we just created. And now you can see the values in the background. They have stopped actually moving. That's because the configuration loading program takes precedence over the monitoring cache of the RCAD server. But nonetheless, we are still monitoring. Users can also, with the configuration loading program, modify blocks or tune blocks. The configuration loading program, as well as the CAD editor, when tuning blocks, employs what we call a smart write technology. Smart write technology pulls the module to determine the type of mode that the module is in before it actually executes the tuning or write block commands. If the module is in execute mode, the smart write technology will permit the writing command to execute a tune block command. If the module is in configure mode, then the smart write technology will permit a write block command to the module. To demonstrate this, let's click on Modify Block. Let's select a block number to modify, and we'll click Retrieve Block, and this retrieves the values out of the module and shows them to you as they are live. If I wish to change a value, I can change it and put it in. But keep in mind here, this module right now is in execute, so we can only change the tunable values. If I try to change a value that is not tunable and try to write it back in, it says that it wrote it in successfully, but if I retrieve this block, you will see that only the tunable value has been retrieved. The non-tunable value hasn't been changed. And this concludes this part of this demonstration on the online capabilities.